Java is a general-purpose computer programming language that is concurrent, class-based, object-oriented, and specifically designed to have as few implementation dependencies as possible. It is intended to let application developers write once, run anywhere, meaning that compiled Java code can run on all platforms that support Java without the need for recompilation. Java applications are typically compiled to bytecode that can run on any Java virtual machine regardless of computer architecture. As of 2015, Java is one of the most popular programming languages in use, particularly for client-server web applications, with a reported 9 million developers. Java was originally developed by James Gosling at Sun Microsystems and released in 1995 as a core component of Sun Microsystems' a Java platform. The language derives much of its syntax from C and C++, but it has fewer low-level facilities than either of them. The original and reference implementation Java compilers, virtual machines, and class libraries were originally released by Sun under proprietary licenses. As of May 2007, in compliance with the specifications of the Java Community Process, Sun relicensed most of its Java technologies under the new General Public License. Others have also developed alternative implementations of these Sun technologies, such as the GNU compiler for Java, GNU ClassPath, and ICT Web. The latest version is Java 8, which is the only version currently supported for free by Oracle, although earlier versions are supported both by Oracle and other companies on a commercial basis. History: James Gosling, Mike Sheridan, and Patrick Norton initiated the Java language project in June 1991. Java was originally designed for interactive television, but it was too advanced for the digital cable television industry at the time. The language was initially called Oak after an oak tree that stood outside Gosling's office. Later the project went by the name Green and was finally renamed Java, from Java Coffee. Gosling designed Java with a C++ style syntax that system and application programmers would find familiar. Sun Microsystems released the first public implementation as Java 1.0 in 1995. It promised write once, run anywhere, providing no-cost runtimes on popular platforms. Fairly secure and featuring configurable security, it allowed network and file access restrictions. Major web browsers soon incorporated the ability to run Java applets within web pages, and Java quickly became popular. The Java 1.0 compiler was rewritten in Java by Arthur Van Hoff to comply strictly with the Java 1.0 language specification. With the advent of Java 2, new versions had multiple configurations built for different types of platforms. J2EE included technologies and APUS for enterprise applications typically run in server environments, while J2ME featured APUS optimized for mobile applications. The desktop version was renamed J2SE. In 2006, for marketing purposes, Sun renamed new J2 versions as Java E, Java Me, and Java She, respectively. In 1997, Sun Microsystems approached the ISO, IEC JTC1 standards body and later the ECMA International to formalize Java, but it soon withdrew from the process. Java remains a de facto standard, controlled through the Java Community Process. At one time, Sun made most of its Java implementations available without charge, despite their proprietary software status. Sun generated revenue from Java through the selling of licenses for specialized products such as the Java Enterprise System. On November 13, 2006, Sun released much of its Java virtual machine as free and open-source software, under the terms of the GNU General Public License. On May 8, 2007, Sun finished the process, making all of its JVM's core code available under free software, open-source distribution terms, aside from a small portion of code to which Sun did not hold the copyright. Sun's vice president Rich Green said that Sun's ideal role with regard to Java was as an evangelist. Following Oracle Corporation's acquisition of Sun Microsystems in 2009-10, Oracle has described itself as the steward of Java technology with a relentless commitment to fostering a community of participation and transparency. This did not prevent Oracle from filing a lawsuit against Google shortly after that for using Java inside the Android SDK. Java software runs on everything from laptops to data centers, game consoles to scientific supercomputers. On April 2, 2010, James Gosling resigned from Oracle. Principles: there were 5 primary goals in the creation of the Java language. It must be simple, object-oriented, and familiar. It must be robust and secure. It must be architecture-neutral and portable. It must execute with high performance. It must be interpreted, threaded, and dynamic. Versions as of 2015. Update. Only Java 8 is supported. Major release versions of Java, along with their release dates: JDK 1.0, JDK 1.1, J2SE 1.2, J2SE 1.3, J2SE 1.4, J2SE 5.0, Java SHA 6, Java SHA 7, Java SHA 8. Practices. Java Platform. One design goal of Java is portability, which means that programs written for the Java platform must run similarly on any combination of hardware and operating system with adequate runtime support. This is achieved by compiling the Java language code to an intermediate representation called Java bytecode, instead of directly to architecture-specific machine code. Java bytecode instructions are analogous to machine code, but they are intended to be executed by a virtual machine written specifically for the host hardware. End users commonly use a Java runtime environment installed on their own machine for standalone Java applications, or in a web browser for Java applets. Standard libraries provide a generic way to access host-specific features such as graphics, threading, and networking. The use of universal bytecode makes porting simple. However, the overhead of interpreting bytecode into machine instructions makes interpreted programs almost always run more slowly than native executables. However, just-in-time compilers that compile bytecodes to machine code during runtime were introduced from an early stage. Java itself is platform-independent, and is adapted to the particular platform it is to run on by a Java virtual machine for it, which translates the Java bytecode into the platform's machine language. Implementations. Oracle Corporation is the current owner of the official implementation of the Java SHA platform, following their acquisition of Sun Microsystems on January 27, 2010. This implementation is based on the original implementation of Java by Sun. The Oracle implementation is available for Microsoft Windows, Mac OS X, Linux and Solaris. Because Java lacks any formal standardization recognized by ECMA International, ISO, IEC, ANSI, or other third-party standards organization, the Oracle implementation is the de facto standard. The Oracle implementation is packaged into 2 different distributions. The Java runtime environment, which contains the parts of the Java SHA platform required to run Java programs and is intended for end users, and the Java development kit, which is intended for software developers and includes development tools such as the Java compiler, Javadoc, jar, and a debugger. Openjdk is another notable Java SHA implementation that is licensed under the new GPL. The implementation started when Sun began releasing the Java source code under the GPL. As of Java SHA 7, Openjdk is the official Java reference implementation. The goal of Java is to make all implementations of Java compatible. Historically, Sun's trademark license for usage of the Java brand insists that all implementations be compatible. This resulted in a legal dispute with Microsoft after Sun claimed that the Microsoft implementation did not support RMI or JNI and had added platform-specific features of their own. Sun sued in 1997, and in 2001 won a settlement of $20 million, as well as a court order enforcing the terms of the license from Sun. As a result, Microsoft no longer ships Java with Windows. Platform-independent Java is essential to Java EE, and an even more rigorous validation is required to certify an implementation. This environment enables portable server-side applications. Performance programs written in Java have a reputation for being slower and requiring more memory than those written in C++. However, Java programs' execution speed improved significantly with the introduction of just-in-time compilation in 1997–1998 for Java 1.1. The addition of language features supporting better code analysis and optimizations in the Java virtual machine, such as Hotspot becoming the default for Sun's JVM in 2000. Some platforms offer direct hardware support for Java. There are microcontrollers that can run Java in hardware instead of a software Java virtual machine. And ARM-based processors can have hardware support for executing Java bytecode through their Jazzle option. Automatic memory management. Java uses an automatic garbage collector to manage memory in the object lifecycle. The programmer determines when objects are created, and the Java runtime is responsible for recovering the memory once objects are no longer in use. Once no references to an object remain, the unreachable memory becomes eligible to be freed automatically by the garbage collector. Something similar to a memory leak may still occur if a programmer's code holds a reference to an object that is no longer needed. Typically, when objects that are no longer needed are stored in containers that are still in use. If methods for a non-existent object are called, a null pointer exception is thrown. One of the ideas behind Java's automatic memory management model is that programmers can be spared the burden of having to perform manual memory management. In some languages, memory for the creation of objects is implicitly allocated on the stack or explicitly allocated and deallocated from the heap. In the latter case, the responsibility of managing memory resides with the programmer. If the program does not deallocate an object, a memory leak occurs. If the program attempts to access or deallocate memory that has already been deallocated, the result is undefined and difficult to predict, and the program is likely to become unstable or crash. This can be partially remedied by the use of smart pointers, but these add overhead and complexity. Note that garbage collection does not prevent logical memory leaks, i.e., those where the memory is still referenced but never used. Garbage collection may happen at any time. Ideally, it will occur when a program is idle. It is guaranteed to be triggered if there is insufficient free memory on the heap to allocate a new object. This can cause a program to stall momentarily. Explicit memory management is not possible in Java. Java does not support C++ style pointer arithmetic, where object addresses and unsigned integers can be used interchangeably. This allows the garbage collector to relocate referenced objects and ensures type safety and security. As in C++ and some other object-oriented languages, variables of Java's primitive data types are either stored directly in fields or on the stack rather than on the heap, as is commonly true for non-primitive data types. This was a conscious decision by Java's designers for performance reasons. Java contains multiple types of garbage collectors. By default, Hotspot uses the parallel scavenge garbage collector. However, there are also several other garbage collectors that can be used to manage the heap. For 90% of applications in Java, the concurrent mark sweep garbage collector is sufficient. Oracle aims to replace CMS with the garbage-first collector syntax. The syntax of Java is largely influenced by C++. Unlike C++, which combines the syntax for structured, generic, and object-oriented programming, Java was built almost exclusively as an object-oriented language. All code is written inside classes, and every data item is an object, with the exception of the primitive data types, i.e., integers, floating-point numbers, Boolean values, and characters, which are not objects for performance reasons. Java reuses some popular aspects of C++ method. Unlike C++, Java does not support operator overloading or multiple inheritance for classes, though multiple inheritance is supported for interfaces. This simplifies the language and aids in preventing potential errors in anti-pattern design. Java uses comments similar to those of C++. There are three different styles of comments. A single-line style marked with 2 slashes, a multiple-line style opened with asterisk and closed with asterisk, and the Javadoc commenting style opened with asterisk and closed with asterisk. The Javadoc style of commenting allows the user to run the Javadoc executable to create documentation for the program. Example. This is an example of a single-line comment using 2 slashes, asterisk. This is an example of a multiple-line comment using the slash and asterisk. This type of comment can be used to hold a lot of information or deactivate code, but it is very important to remember to close the comment. Asterisk, package fibs import Java, util, hash map, asterisk. This is an example of a Javadoc comment. Javadoc can compile documentation asterisk from this text. Javadoc comments must immediately precede the class, method, or field being documented. Asterisk, public class fib calculator extends Fibonacci implements calculator, private static map less than integer, integer greater than memoized equals new hash map less than integer, integer greater than memoized.put, system.out.println, get the 12th Fibonacci number and print to console. Asterisk. An example of a method written in Java, wrapped in a class. Asterisk, given a non-negative number fibindex, returns asterisk the nth Fibonacci number, where n equals fibindex.